Hello, my name is Joseph Shipley, and I'm presenting my senior project proposal on thermoelectric power generation, specifically towards wearable device applications. And so just a little bit about thermoelectric power generation for those of you who haven't heard of it or know very little about it. Um, it's basically you just take two plates. One plate has applied heat, for example, your skin for a wearable device, and the other side should have some difference in temperature to that. And that difference is able to generate a current that is then used to power and help provide battery life. So part of my motivation or reasoning for wanting to do a project like this is I work for a company that sells wearable devices for the elderly. And oftentimes you get complaints that battery life is not very long or doesn't last very long. And so I was interested in seeing if there's a way to improve that battery life, and this is one of the methods that I came across that piqued my interest. There is some existing technology out in the field that's being sold to customers, but I was shocked at how little there actually was. Some products that Matrix Industries has developed are on the left, we have the Power Watch, and this will do most of what any regular watch would do, along with athletic features and health features that the thermoelectric power that it is able to generate helps to keep the battery life up. And another product that they have is called a Perceptive that you can see on the top right. This device actually is completely run on renewable energy, so it uses thermoelectric energy as well as solar energy to power it. And below the Prometheus is the thermoelectric generator that actually does all the work to get the difference in temperature turned into a strong current or power supply. For the project that I am proposing, I would like to ultimately do an analysis on current TEG or thermoelectric generation generators, just do an analysis on what technology there is out there and how well each one performs. I'd like to ultimately completely implement this onto a wearable device and hopefully improve battery life. Some technology that I would be using in the project would one be an ESP32. I would have to put code onto this device to generate differential temperature logs that I could see and analyze, and also it would be able to just show how much power is being generated based on that differential in temperature. 4 different TEGs that I've found online that would be viable for this project of implementing onto a wearable device. I would be testing and analyzing. A voltage booster is used for amplifying the signal that comes through. I did find that the signal that thermoelectric generators produce isn't very strong, and so a voltage booster would allow that to be amplified so that it's usable energy. And finally, a temperature sensor would be the last of the hardware pieces that I expect to be using for this project, just to record the temperature of each part of the thermoelectric generator. Some software I'd be using is C, C++, and Python. The C and C++ would mostly be for the ESP32, and the Python would be for the analysis portion of the project and just displaying my results. Some of the costs that would go into this would include buying the ESP32 board, along with all the thermoelectric generators that I could find online that would fit the parameters of the device that it would be going on to. The voltage booster is another product that I need to purchase to test out and see its capabilities. And measurement tools, temperature sensors, multimeter to test power and power supply as well. The ones in asterisks, if I were able to get it sponsored by my employer, would be provided by them as well. So those wouldn't have a additional cost associated with them. Some milestones I hope to achieve along the way is to just do some more research on thermoelectric generation and how it can be improved, what has been done to try to get it better. From what I've already researched, most people say that it's not worth our time to use thermoelectric generation just because it doesn't provide a strong enough signal. But I believe that there's just not enough research that's been done to see what the scope of the thermoelectric generation can what it can achieve, and so that would be a big part of my project, is doing research and seeing how it can really help and benefit small scale devices such as the wearable devices I would be implementing the TEG onto. ESP32 code would be just making sure that it works properly, that I can get an output of logs that display the difference in temperature, that I can then translate into power generation and how that works, how that is done on each device and how well each one performs, and then determining the best TEG. And finally implementing the TEG onto an actual device and seeing its performance, and if it actually does improve the power or if it's just a waste of time. This is my timeline for the project. I'd start by trying to get Freus, the company I work for, to sponsor my project. I begin researching, or doing some more research on the thermoelectric generation, finding parts for testing it, the ESP32, already talked about that. And then I spend a decent amount of time putting test equipment together and making sure that the code works from the ESP32 and connecting monitoring equipment and things like that. Then I'd start analyzing for the different sensors, and each one I'm guessing will take a decent amount of time. That's why I allocated a few months for that, to just perform testing on those sensors and to see all their capabilities, and then to ultimately select the best one that would work best for the wearable device that Freus sells. And finally, testing on that wearable device would be the last step of the project, and getting it to connect properly, testing it out, measuring battery life, and doing an analysis of the battery life difference with and without the TEG. Some deliverables for the project is just data collection, getting temperature difference logs, getting power output logs from each device. I'd also like to do a demo using LEDs on the ESP32 just to show how the thermoelectric generators work, and showing that they do work, in fact. I want to do an analysis of each thermoelectric generator and show my findings and report it in an organized fashion using Python. I'd also like to just get the implementation to actually work on the Bell W, which is what the device is called that Freus sells, and then show some charts just how the battery life improves through the thermoelectric generation. All in all, this would be a really good research opportunity for me to expand my knowledge on wearable devices and how things fit into the device, and how we could implement some sort of method of improving their battery life. And I believe it would be a really innovative idea that would that could have a lot of potential for wearable devices, not just medical small scale devices, but even moving on, it could, if we can get it good enough, it could improve battery life for more than just small devices, and so I think it has a lot of potential. These are the sources that I used. Are there any questions?